Hey everybody, so we are finishing up. This is the last of the quarter one review. This is part 5 of your quarter one review. This is going to talk about being able to determine if something is a function by looking at their solution sets, using mapping diagrams, vertical line test, and then putting it all together with the arithmetic series. Is this an arithmetic sequence that's going on? Can you see a pattern that has a constant rate of change in there? So let's take a look at 31 to start off with. It says use a mapping diagram to determine whether the relation is a function. So you have a set. Remember the pointy brackets say here is a set of things. So it's more than just a number. It's something's going on there. What is it a set of? It's a set of ordered pairs. These happen to be a bunch of solutions to a particular equation, and they want to know, is this equation or the relationship, this is a function or not? Okay, so we look, each x, we have an x is 5, the y is 7, the next ordered pair is 2 is the x, 6 is the y, the next one is 2 and 9, the next one is 8 and 5, 4 and 14, 5 and 4. They want us to know, first off, is this a function? And of course, we know if it's drawn on a graph, we can say, oh, look, use our vertical line test. If it only touches one time, that vertical line we draw, we know that it is a function. More than once, it's not. We don't have that. So we can create a mapping diagram very easy if we understand what makes it a function and what doesn't make it a function. So the domain, or your x's, is here. Range is y, and they have 3 of them here. Your x's, your y's, your x's, your y's. So each of these x's need to appear, make sure that they're in the box, okay? And if they duplicate, we don't write them 2 times, we just leave it once, okay? So 5, is 5 in this one? Yes. 2, is 2 in this one? No. Not that answer. 5 in this one? Yes. Is 2? Yes. Notice, look what they just did here. They duplicated our 2's. That's going to give us, while it's all these are right, they have all the numbers right, we don't duplicate 2's, and we do it for a reason. Okay? So it's not this one. 5, yes, we have a 5 there. All right, 2, yes, we have a 2. There's 2 2's, and you see it makes the V. There's an 8, yep, a 4, yes, and look, another 5. Okay. So we look at this now. Yes, we can say this is the proper mapping diagram, and they all go to the appropriate numbers. 5 to 4, and 5 also goes to 7. 2 goes to both 6 and 9. 8 goes to 5, and 4 goes to 14. Now it wants to know, is this a function? And if you remember Mr. C's V test, if you can hold up your left hand and you see a V coming out of that bubble, or the domain bubble on the left side, it is not a function. Each x has to be unique. You cannot have more than one x at all. So even if they don't give you a mapping diagram and all they give you is a solution set, you look. If any of your x's repeat, it's not a function. So see how the 5's repeat? Right away, not a function. Your 2's repeat, definitely not a function. If you look at this and all your x's are the same, or all your x's are different, that's the easiest way to look at it. All of the x's are different, it is a function. If any of them repeat, it's not a function. Let's move on. So what is f of 3? So function notation. Normally function notation looks like this, f of x. Okay, like it says here. What is f of 3? For the function, f of x equals 7x plus 6. Notice, if they're asking f of 3, what is f of 3? They replaced the x in the function notation with the 3. They substituted it. So use your rule of substitution, and you do the same thing. 7, get rid of the x, and you can put a 3 in, plus 6. Great. And then you do your math. Well, 7 times 3 is 21. So f of 3 is going to equal 27. And of course, you can always test it if you want. Let's look at the next one. Use the vertical line test. So we just talked about that. Vertical line test means hold up your ID card, your pencil, your finger, stand back, take a look, eye it up. If you can draw a line that is vertical, like the y-axis is a vertical line, if you can draw a vertical line and it only touches at one point, come over here, it only touches at one point, that is a function. Notice there's no, it doesn't zigzag over like this, where if we were to draw a vertical line, it would then touch 3 times. Or like this, where it would touch twice. Okay, so be careful. Remember piecewise functions? Here's another example. If we had something that looked like this, where you have a solid dot, and right underneath it is another solid dot. This, if you were to draw a vertical line, would not pass that vertical line test because it intersects twice. One of those two dots would have to be open. So remember, vertical line test, if you draw a vertical line and it crosses more than once, it's not a function. Look at this one. They want you to use that vertical line test. You do it. Is it a function? Is it not a function? Here we go. Find the range of the function for the given domain. So again, remember, look at these parentheses here. These parentheses are these pointy parentheses. This means it's a set. Well, what is it a set of? It's a set of domains, or a set of x's. We need to know that domain means x. In this case, they said it's a set of them because it's in these pointy parentheses. Well, they gave us a bunch of x's, right? And we have a function f of x. What do you think we do with x's if they give us a whole bunch of them and they want to know, well, which range is correct? So for the given values of x, they want you to substitute each number into this equation. So yes, please don't be lazy. You're going to have to solve that equation 5 times to make sure you have the right answer. So you're going to do f of -2, which means you have 2 times -2 minus 4. Then you're going to do f of -1, which means 2 times -1 minus 4. And you keep going. Start off, 2 times -2 is a -4. -4 minus -4 equals -8. And so on. So you're going to do it 3 more times and get your 3 more answers. So right away, -8. Take a look. I didn't give you the answer away. I helped you eliminate one. And everyone's problems are different anyways. Very few of you will have the exact same problem that we have here. But imagine this, the very first one, you can't solve one problem and just get the answer. When you solve one problem, look, -8 shows up 3 times for that first solution. You can eliminate B, but now you have to then test the next one. And notice, I'm going to guess the next one is probably going to be -5 because they're going to make, there's 2 of them here. Okay, so think about it. And oh, look at this, -2, or 2 times -1 is a -2. -2 minus 4 is a -6. Ooh, maybe they were nice to you. So here, it's not -5. By process of elimination, you didn't even actually have to solve them all, but you have to start, okay? There's 5 x's, you got to plug in 5 x's to get your 5 y's. Which one lines up exactly? The last 2 problems are, this is the arithmetic sequence. They want you to predict what, given this particular sequence of numbers, what is the next 3 numbers going to be? So you have to look at this. These are your y values. So what is the difference or the change in value from one to the next, one to the next, one to the next? Well, 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. 13 minus 11 is 2. So every time another y is added, it's going up by a factor of 2. It's going up by 2. So you can now predict what this one, and this one can be. You add 2 to 13, then you add 2 to the next number, and you add 2 to the next number. Do we need the fancy formula for this? No, we don't. We just need to be able to recognize the pattern that's happening in our responses. This is a linear function because the rate of change from one value in the domain to the next is staying a constant number over and over and over again. And that's what the last two are asking you to do. All right, this finishes our quarter one review. All of quarter one summed up in 37 problems. Hope you guys have been paying attention to the videos. Please subscribe so that you have access to all the videos to help you with this. All right, finish up this review. Have a great weekend.